As of 2012, there was 9.2 million dairy cows in the United States, with these cows producing 200 billion pounds of milk per year. That equates to each cow in the United States producing 21,697 pounds of milk. Now, this high milk output can be contributed to several factors, but the main two would be increased management and knowledge of farmers, but also the high volume of Holsteins that make up the United States dairy herd. Currently, of all the cows in the United States, 93.5% are Holstein cows. Holsteins have become prevalent in the United States due to their genetic selection for higher milk production, but also due to their large size, which allows them to have a higher dry matter intake per day, resulting again in a higher milk production. This is advantageous for most producers. However, with over 32% of the milk produced in this country coming from the Southwest region, this also results in a challenge. The challenge being how to adequately cool a high-producing dairy cow to maintain proper milk production and prevent heat stress. The United States dairy industry sees a $900 million loss each year due to heat stress. There are many methods to cooling cows. However, this video will focus on cooling methods in the holding area directly preceding the milking parlor. But first, let's follow a cow in her normal daily routine. This is an example of a freestall barn where cows would spend the majority of their day. At milking, the cows will exit the freestall barn and arrive in the holding area directly preceding the milking parlor. The holding area is where cows will stand as they await their turn into the parlor. Depending upon the size of the holding area and the size of the parlor, cows can spend 15 to 75 minutes awaiting their turn in the parlor. Depending upon if the dairy milks once daily, twice daily, or 3 times daily, the cow can spend up to 15% of her day standing in the holding area awaiting to be milked. Bob Collier and colleagues from the University of Arizona have shown that dairy cows experience the highest level of heat stress when in the holding pen. This is mainly contributed to the large density of dairy cows in a small space. The combined body heat of the cows, along with the respiration, creates a microenvironment around each cow that is much warmer than room temperature. This leads to some cows experiencing heat stress unless proper cooling is in place. Milk production is negatively affected by heat stress, with 2 pounds per cow per day lost in the holding area with improper cooling. 2 pounds per day times 300 days of lactation, combined with a moderate average of $16 per hundredweight for milk, results in a $9,600 loss for a moderately sized 100 cow dairy. Producers can take advantage of natural ventilation to aid in cooling, or perhaps change the time of milking to a cooler portion of the day. These methods can produce some logistical challenges, however. They also both rely on heat loss methods such as conduction, convection, and radiation that are thermal gradient dependent, or what we refer to as sensible routes of heat loss. Evaporative cooling is the only heat loss method which operates on a vapor pressure gradient, or what we refer to as an insensible route of heat loss. Therefore, evaporation is the most commonly used method of heat loss when ambient temperature is close to body temperature, as is often seen in holding areas. Evaporative cooling works by wetting the skin of cows and dissipating excess heat from the skin as the water evaporates. In dairy applications, sprinklers are most commonly combined with fans to maximize evaporative cooling. Most dairy cooling systems operate with an automatic thermometer which activates sprinklers and fans when ambient temperature reaches 70 degrees Fahrenheit. The volume of water applied through sprinklers is also important, as too much water increases the wastewater and also decreases the hygiene of the cows. The optimal volume of water applied is enough to wet the backs and the sides of cows, but not the udders. Water should also be applied every 1.5 minutes out of every 6, with a minimum of 0.05 liters per square feet applied at a pressure of 15 to 30 psi. Sprinkler nozzles should also have a 360-degree range of application with an average reach of 8 feet per sprinkler. Nozzles should also be placed approximately 7 feet apart and a minimum of 7 feet above the ground for maximum effectiveness. As stated previously, in dairy operations, fans are often added in addition to sprinklers to increase evaporative cooling. When ambient temperature is between 68 and 72 degrees Fahrenheit, Fans should run regularly except for times when sprinklers are active. Once ambient temperature reaches 72 degrees Fahrenheit, fans should run continuously to maintain proper evaporative cooling. Fans should be mounted overhead, a minimum of 7 feet above the ground, but as close to the animals as possible, with a downward angle of 30 degrees to maximize the air movement across the backs of the cows. Fans 30 to 36 inches in diameter can be used and should be mounted in groups of 3, side by side, with approximately 5.5 to 7 feet between each group. These groups then can form rows, and rows should be spaced evenly every 20 feet of the entire length of the holding area. Larger fans, up to 48 inches in diameter, can also be used, and should be mounted in groups of 2, again with 5.5 to 7 feet between each group, and these rows of larger fans should be spaced evenly every 40 feet the entire length of the holding area. Proper cooling in the holding area not only keeps cows happy and healthy, but also protects against the loss in milk production, increasing the productivity and profitability of a dairy operation. Producers in the United States should strongly consider holding pen cooling systems, especially in warm climates. Thank you for your time, and please refer to these sources for any additional information.